Okay, we're looking at interpreting some exponential functions, and so this really gets into actually using these functions in a real life scenario to figure out what things mean in a financial situation or buying something, selling something, figuring out decay or growth in a certain situation. So the formula we'll use for growth is y equals a, which will be our starting amount, times 1 plus whatever the rate is. And normally that rate's going to be pretty small. Should be less than 10% almost any time you see it. Otherwise, you just get a very large, very fast growth, like when we've done to 2 or 4, like that goes up very quickly. You're not going to find situations where you can get exponential growth that doubles every year or quadruples every year. And so that 1 plus r, that was our b value. And so that b value is turning into 1 plus whatever the rate is. And then x, which will be our time. And so that is our growth function. Our decay function, y equals a, which again is the starting amount or the y-intercept, times 1 minus r to the x power. So if it's growing at 2% a year, it'd be 1 plus 0.02. If it was decaying at 2% a year, it'd be 1 minus 0.2. So this one would be 1.02, and this one would be 0.98, which would make that a decay. So A is going to be our starting amount. R is going to be our rate as a decimal. X is normally going to be our time. And B gives us that B value, gives us our growth or decay factor. But just as we're breaking it apart, we can kind of look at that. So let's look at our first one, and we're just trying to pull apart what it asks us here. So the function A is t power equals 4,500 times 1.025 can be used to determine the total balance of a savings account after t years. So what does each value in this function represent? So we have 4,500 is the starting amount. Starting amount, you could write that as the initial investment, the money that the account starts out with. So you have 1.025 equals 1 plus the rate. And so to figure that out, I need my rate. So this 1.025 is a growth factor. That means my rate equals 0.025, or you could write it as 2.5%. So just remember that when we're showing that percent there, that we move the decimal place back to get that rate as a decimal. And so that's the growth rate. Okay, and then your t value, it already told us was time. And so really we're just breaking apart and getting that information there of what is each part of it. Now looking at the next one, it's 2010, the population of a town decreased at a rate of 2.9% each year. 2010, population was 11,346. Write a function that represents this situation. What does each value represent? So let's start out with the A value is 11,346, and that is starting population. And the R value is going to be 0.029. Just change that from the percent. That's the rate of decay. And so to figure out my formula, I would need my B value. So B equals 1 minus 0.029. And we could plug that in the calculator real quick, or just say 1.000 minus 0.029. So 10 minus 9 there gives me 1, 7, and leaves that as a 9. So 0.971. So my formula would be y equals starting amount times 0.971 to the x power, and where x would be my time. And so that is I know we ran out a little bit of room there, but that's our formula for that. Okay, now we've got here graph showing the value of a stock over time. And so the function's y equals 280 times 0.76 to the power of x. That represents it. And so that's going to be number of months, it looks like. And this is probably not a stock you'd want to invest in because that is going down pretty quickly. But getting that information, and really we can just go off of the formula that we have there. The 280 is the starting amount. So it starts with 280. The B value equals 0.76. And so since that's a decay, we'll say 0.76 equals 1 minus the rate, which means I would, if I'd subtract or add the rate to both sides, basically we'd swap these, and to get whatever R is, we'd take away 0.76 from 1. So 1.00 minus 0.76. So R equals 0.24 at 24% rate of decay. So that's, I said you won't see that often, but that is a decay going down pretty quickly for the number of months there. So breaking that apart again, looking here, if I did 1 minus 0.24, that gets me 0.76. That's kind of how I got my process there. It's all just working with fact families. Then we've got number of clients a business has over time. I want to know how many clients did the business have when it started if the function y equals 100 times 1.36x represents the situation. So the 100 there would be our starting number. So that's really all it asks you for there. But we also want to know what the rate is. Oh, it also asks what is the growth rate. So the growth rate there, we have b equals 1.36. So we know 1.36 equals 1 plus r. So if I take away 1 from that, then r just equals 0.36. And the decimal over twice, that would be 36% growth rate. Okay, so you're really looking at this just as identifying different portions of this as we go along. So the patient takes 50 milligrams of pain medicine for each hour, 45% of the medication remains. What's the exponential function? So A, or the starting amount, would be 50. And it doesn't say that 45, it doesn't say it loses 45. It says that's the amount that remains. So the B value is actually going to be 0.45, which means I could just write my equation and say y equals 50 times 0.45 to the x power. Since it didn't say it decreases at this rate, it says you have that much left after each hour. So because it didn't give us a decay rate, and it just gave us, or it didn't give us the actual rate of decay, it gave us how much was left. That's our multiplier. So kind of makes it a little bit easier on us. Then you've got scientists increasing a fish population. There were 150 or 104 at the beginning of the study. They're increasing it by 9% each year. So A equals 104. The rate equals 9% or 0.09. And so when we're writing that function, we'd start it out y equals 104 times 1, that's growth, plus 0.09 to the x power. But we just combine those to say y equals 104 times 1.09 to the x power. So this is just getting you really familiar and really comfortable with how these look, how you're going to see them in word problems, because they will pop up like that on you often. Oh, I will let you look at those and see which interpretations would be true to get an idea there. And remember, on those, you can have more than one. So I think there's one here and maybe two here as you're looking at that.